and then it would tell you like the salinity or
oh yeah.
all that kind of stuff.
I saw that listed. Yeah, I think it's a good project. It's got hardware, it's got software, it's got communication. All right, how's everybody doing? So this is our last class for like 3 days. There's no class tomorrow and weekend, so it's a 3-day weekend for students from Clark classes at least. So I want to talk about 411. I want to talk about lessons from ODP 411. I want to go over ODP 412, your last ODP for the week. I want to talk about some fun stuff and show a video and talk about gets and do some hacking, and then talk about VI. So we got a bunch of different things going on today. And the sign-in sheet is going around, and it may not have started in the front, so I'll send it around the front when it comes back. So any questions before we start ODP 411? Yeah?
So I remember looking at your introduction videos, by the way, those are amazing.
Cool, good, thanks.
And you said that FGetS has, its own issues with use. But then you said that scanf has issues as well. So when we were talking about, using scanf, you said if you just want user input, use GetS. But GetS has its own issues. So I was wondering, is there any reliable way to get a user input?
FGets is the reliable way. There's no issues with FGets. There's issues with gets. But FGets is totally safe and solid and advised to be used.
Oh, so there's...
Yeah. So gets is the one that's deprecated and dangerous. And we'll see why in a little bit. And then scanf is the one that I recommend you use, not scanf. Okay, so fgets and scanf, happiness and joy. Gets and scanf, All right, so let's look at ODP 411. So first of all, some code, right? So here's a working parse function for ODP 411. Similar to the code that we went through yesterday and that was posted on Canvas. Function name is parse, returns an integer, takes a char star. Some temporary variables. You always need an int I somewhere in your program, otherwise people think you're not a programmer. And my temporary array temp holds 1,000 characters. And then here's the magic line scanf. So take the argument and try to convert it as an integer followed by stuff. Save the integer in I, save the stuff in temp. If the return's not exactly 1, it means it either didn't find an integer or it found an integer, but it also found some stuff after it. Both of those are errors, in which case we return the error code of -1. If return is 1, it means it found an integer but no extra stuff. So in that case, we just have to check the value of an integer. If the integer is bigger than or equal to 1, less than or equal to 3, we'll return the integer value. That's what we want. Any other condition, we're going to return a -1. For example, they typed in the number 55 million. That's outside the range. We'll return the error code -1. All right, so why are we doing ODPs? It's not just to give you extra stuff to do. The ODPs are designed to exercise your understanding of some concept or set of concepts. In this case, mostly we're working with this idea of scanf and using it to parse input, to say, is this just an integer, or an integer with other stuff, or not an integer. And most people probably spend a good amount of time on this ODP. Okay, so I peek in on Discord sometimes. I get log files every time you assess. Most people, this was not a slam dunk. So, thanks. Did you get these? So, when the ODP is done, it's useful to sort of take a step back, take a breath, and ask, what's the take-home message from this particular assignment? Right? What have I learned here? Why was it a challenging assignment? What were the major battles that I had to fight here? It's not that the code is particularly long, right? It's a pretty short program, 11 lines in this case. So what I want to do is take a few minutes and ask, what is it in here that was most challenging, or that maybe still doesn't make sense? Because sometimes we just keep changing things and submitting until we get 10 out of 10, and we're getting warnings and 80 things we tried before it didn't work, but we got 10 out of 10, so we're done. We go on to linear algebra or physics. But what is there in here that either was very difficult to nail down or that is still kind of confusing? And I want to just kind of talk about a few of these things. And I guarantee almost everybody in the room right now has confusion about something in here, okay? And most people may not raise their hand, but that doesn't mean that you're the only one who has questions. So if you want to just kind of like pick something in here, what's potentially weird in here? What's not totally clear?
I guess we can start with having two things to search for in the scanf.
Excellent. Because we're trying to convert an integer, why do we have two things, a %d and a %s? So scanf is a real powerhouse tool, okay? And I mean scanf, but I'm going to say scanf. Scanf does some amazing things. In our case, we're using it to check for an integer. And I may as well stick with the variable names I have in there. So arg. And let's just say address I, where I is an integer. And suppose that arg is equal to 256. Okay, and there's a null terminator at the end. So what does scanf do? It always starts at the beginning of this string. Looks at the first character and it says, could this be part of an integer? Yeah, it could. Okay, so it tucks away at 2 in its mind. It goes to the next character. Could that be part of an integer? Yeah. How about that? Yeah. How about this? No, that's a null terminator. Okay, so it looks at what it saw so far, which is 256. It does some arithmetic. It multiplies 6 by 1, 5 by 10, 2 by 100. It adds those together. It gets 256. It loads that into the variable I. And it says, all right, boss, I converted one thing, so it returns a 1. All right, the problem is if arg equals 256, haha. Is that an int? Yeah. Is that an int? Yeah. Is that an int? Yeah. Is that an int? No. It takes the things that it found, it converts them. It's 256. It loads that into I. It says I converted one thing. It returns a 1. The exact same behavior, whether the input was a simple integer or an integer followed by other stuff. If your argument was 256.7, that's part of an int, that's part of an int, that's part of an int, that's not part of an int, it's a decimal point. Takes what it found, loads it into I, returns a 1, exactly the same. So we need some way to differentiate between was the input a number, or a number followed by a word, or a number followed by a period, right? So we add a %s. All right, let me do this officially. All right, so 256 with a backslash of 0. Integer, yes, integer, yes, integer, yes, integer, no. Okay, so this matches an integer. Let's take that, convert it, 256. Let's load that into I. Okay, we used up the first 3 characters. Let's look at this 4th character. Could this be the start of a string? No, it's a null terminator. So it cannot load anything into, it can't match anything to a string. So it does not do anything with temp. And it says I converted one thing, so it returns a 1. All right, if your argument equals 256, haha, integer yes, integer yes, integer yes, part of an integer no, takes what it matched so far, that's a 256, loads that into I. Now it looks at where it is in the string, that's the H. Could that be part of a string? Yes. A yes, H yes, A yes, null terminator. Nope, that's the end of the string. It takes this, makes a string out of it, throws its own null terminator on the end, puts that into temp. Now it says I loaded 2 output variables. I converted 2 things. It's going to return a 2. Okay, and exactly the same thing if it's 256.7, integer, 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 not an integer. 256 goes into I. Period is part of a string, yes. 7 is part of a string, yes. It's going to take 0.7, load that into temp, it's going to return 2. So by adding this extra stuff at the end, we have a way to differentiate these cases. If it returns 1, we had a single integer and nothing after it. If it returns 2, we had an integer with something after it, which we consider to be an error case. So that's a trick, right? If we just wanted an integer, we didn't care what came after it, we could just say %d. But by forcing it to convert something afterwards, if it succeeds, return will not be 1, it'll be 2. And we can say that there's more than there should be on this line, and so we return the error code. Make sense? All right, so what else is strange in here? I can think of 3 or 4 things.
In the broad sense of the word, what specifically, that didn't make sense.
That's okay.
Parsing. What is parsing?
So parsing, when I use the word parse, I'm saying let's take typically a string of characters and interpret it in some way.
Okay.
Right? So the character string 256, it's ASCII code 50, an ASCII code 53, and an ASCII code 54, and an ASCII code 0. It's 4 bytes that represent a 2, a 5, a 6, and a null terminator. And we can't add something to that. If we take string plus 1, we'll get a compile error. So it's interpreting that as, let's treat this as an integer, and let's actually create an integer equal to that. Okay? Or let's treat this as a hexadecimal number. Maybe it's 256 hex. So it's 2 plus 5 times 16 plus 6 times 256. Right? Or maybe it's octal, it's base 8. And more generally, you know, somebody may say something like echo hello. Well, how does the shell know that it should respond to that by saying hello? Because it looked at my input, ECHO space quote HELL quote new line, null terminator, and it said, oh, this is an echo command because the first 4 characters are ECHO. So I need to find out what they want me to echo. There's a space, it ignores that. There's a quote that starts a string, it moves till it finds another quote, it takes the stuff in between, it's got the word hello. Oh, this person wants me to say hello. And so it prints out HELLO to the screen. Okay, so the process of doing all that is basically parsing this line of input, right, this string. So parsing is basically interpreting or understanding what a string is saying or asking. And I mostly use that term in contrast to input, right? Inputting a string is something like fgets. It's just saying, just read in a bunch of characters and stick them somewhere in memory. That's an input operation. Parsing is, let's look at that string of characters now and let's interpret it in some way. Bless you. So if it's a 2 and a plus sign and a 3, we might say we want to interpret that as an addition request. And we want to add 2 and 3 and we'll print out a 5. We'll talk some about parsing at the end of 215 when we talk about like language processing and grammars, and that gets into sort of understanding a string as you know what it means. Yeah.
So I still get confused by like pointers and dereferencing pointers and all that, and like you do the character and then you do the asterisk and then your thing. What exactly is that again?
Okay, awesome, thank you. So this is I think the most confusing part of all of this stuff. So let's talk about strings and character arrays for a minute. We sometimes do something like this. Char temp bracket 120. And this says I want temp to be an array of characters. Okay, if you're in C, array of characters and string, same thing. You hear string, think array of characters. You hear array of characters, think string. So this is an array of characters, this is a string. We're telling it how long this array is. It holds 120 characters. Sometimes, though, we do this. Car star, name of a variable. That is also an array of characters. It's also a string. And in this code for parse, right, in the declaration of the function, we said car star arg. A few lines later, we said car temp bracket 1000. They're both strings. How do we know which one to use? Why do we use one versus the other? And while we're here, I could say car space star arg. I could say car star space arg. I could say car space star space arg. I could say car star arg with no spaces. They're all exactly the same. Okay. Generally in C, if the spaces are required to make something unambiguous, then you got to put in spaces. If you don't need spaces to make things unambiguous, they're usually optional. So space after a semicolon or things like that, right? Completely optional. So I usually write them like this, car space star arg, but whatever feels good. All right, so why is this car star arg and this is car temp bracket some size? So both of these say this variable is a string, an array of characters. This does some extra stuff that doesn't do, though. So if we say car temp bracket 120, what does the compiler do? It says, okay, the person is going to use this variable named temp somewhere, and that's going to be an array of characters. And that has to be big enough to hold 120 characters. So it will find somewhere in memory a spot that's at least got 120 spaces. So somewhere in memory there's a spot where there's 120 bytes. And it will take the address of that first byte and it will say temp is that address. So it finds a chunk of memory and then it sets temp to be equal to the address of that first byte in this chunk of memory. Car star arg doesn't do anything. It's really just kind of making the compiler happy. Oh, I know what arg is. It's a pointer to a character. It's an array. It doesn't look for space anywhere in memory. It doesn't give arg a value. It's really just saying when you see arg, it's a character array. But this is saying when you see temp, it's a character array. Oh, and by the way, temp is equal to, 522. And at location 522, there's a block of memory that's not being used by anything else. You can use that for temp. So let's write some test code. I've got my car temp 120, I've got my car star arg. Let's just print out the value of temp and arg. And I'm just going to print them as numbers. I'm going to use %x to make it come out in hex, because hex is fun. I'm just going to print temp. Now remember, this is the other thing to keep in mind about arrays. If you have an array named temp, the word temp, T-E-M-P, means the address where the array starts. Okay, it's synonymous with the address of the first element. When I say arg, since arg is an array, arg means the address of the first element in that array. So addresses are basically integers. They're big integers. But I'm just going to print it out with a %x. The compiler will complain, but it'll let us do this. Okay, so let's see what these things are equal to. So there it's complaining. Let's go ahead and run go. Temp is equal to F8EA5DA0. That's a memory address. And at that location, there's 120 bytes starting there, whose whole purpose is to hold the elements of temp. But arg is equal to 0. Because when you say car star arg, it doesn't initialize arg. It doesn't make it point anywhere in particular. It doesn't set aside memory anywhere. It's just saying arg is an array of characters. And this is this thing that each time you run it, you get a different value for temp because it depends where things get loaded in memory. That original block of memory might be in use now. So got a different block. All right, so we're using scanf. We're taking the second thing, the stuff that comes after the integer. We want to store that somewhere. We don't care what the value is. We just want to know if there was something after the integer. But scanf is going to take whatever it finds, whatever that string is after the integer, and it's going to store it in a variable. So we've got to have a variable that has some space available. So temp I declared to be an array of 1,000 characters. Why? Because I figured 1,000 is a big number. Technically, that's a little dangerous. It could be an overrun somewhere. But, 1,000 characters, if your teacher's not crazy, that's probably enough space. So I had to actually declare space for TMP. So that's why I said car temp 1,000. But the argument to the function parse, I said car star arg. Now, this is a function. What's happening? We have a main program. It's doing some stuff, and at some point it says something like, result equals parse something. Okay, when you call a function, what happens? Let's write our prototype up here, integer parse car star arg. When you call a function, what happens? You have a set of parameters separated by commas. We only have one parameter here. The value of this argument gets copied into the value of this variable. Okay, so if I'm expecting an integer and I call parse parentheses 5, that integer will get set equal to 5. That's how we pass things to functions. So in this case, assuming that something is an array of characters, something, 9-letter word, means the address of that array, the address where the array starts. That address will get copied into this variable arg. So now arg has actually got a value which points to an array of characters that happens to be called something in my main program. Is there enough space for that array? Well, as long as main actually declared an array in a reasonable way where there was space and there's meaningful characters in there, right? That's all fine. Arg will point to the beginning of that array. So exactly what I want in here is car star arg. I don't want to define a value for arg when I'm writing my parse function. I just want to say arg is at some point going to point to an array of characters. And then when you call it, the address of a real array gets copied into arg. And now when we use arg in this parse function, it's pointing to this array of characters. Yeah?
So this might be weird. If you're sending the address of like a string of characters or anything to a function, and then that function looks there and modifies the contents of that address, and then it gets out of that function and goes back to where it previously was, are those contents still modified by that function? So it's kind of like a global variable without using global variables.
Kind of, yeah. What it's technically doing, the technical term you see is it's mimicking pass by reference instead of pass by value.
Okay.
And that's a deeper discussion that we need to have at some point. But yeah, that's exactly why we do this, because, well, for example, when we call scanf, that's just another function, right? It's a function like parse. And we're passing it an argument, which is an array of integers, an array of characters. But this function will change what's in that array. And when we come back here after the function returns, that array has been changed, right? What it's not going to do is change the value of TMP. That's the address where the array is. That doesn't get changed. But what's stored at that address, yeah, that can be modified.
What if you wanted to store both the original array and like make a modified version?
So your function could create a new array.
Okay.
This is where we get into malloc, which we're not at yet.
Oh.
But that's where you grab a new chunk of memory, right? And then we could load some stuff into that.
I think Koss talked about that.
Yeah, it comes up in 121, but usually not very deeply. We'll be living and sleeping and breathing malloc in 222.
Cool.
So we got time for that. All right, and same thing with I. If we just pass I to a function, we can't change the value of I. We're passing the address of I, and so the function can change what's at that address. That's exactly what scanf does. So that's how it returns a different value. All right, other weirdness in here. So here's one other thing that I think is a little weird. There's an ampersand in front of I, there's not an ampersand in front of TMP. So scanf is trying to change the value of arguments, right? If we're reading an integer, we got to change that integer. When we come back from scanf, the value of I should be whatever the integer was that it parsed, right? I didn't even give I an original value when I said integer I didn't say I equals 5 or something. It really has no fixed value, but when I come back from scanf, I should have a value suddenly. Well, the only way it's doing that is because I'm telling it where I is stored in memory. And if it knows, oh, here's where I is stored in memory, it can go to that location, it can write a new value there. And now in my main program, when I look at I, what do? I come down to this location in memory. What's the value? It's that value that got written by scanf. Same thing with temp, but TMP is already an address. It's the address of the first element in the array. So I don't want to say ampersand TMP unless I'm asking scanf to change the value of TMP. And I don't want to change that because the value of TMP is a location in memory where the array is stored. If you really want an ampersand, you can do something like this. Right? TMP is actually the same as ampersand TMP bracket 0. It's the address of the first thing in the array. So by saying TMP, we sort of are putting an ampersand in there for scanf. But ampersand TMP bracket 0 is just kind of begging for confusion. So arrays, we just use the name of the array.
So I'm kind of confused again. So for arg, because when you pass it through parse, it becomes a value, right? Because you have
So let me show you the main program. Right, so here's the main program. So I had a buffer of 120 characters, which I declared to actually set up space. And then I call fgets, which reads from the keyboard and takes whatever is typed in and stores it in buffer. And then I call parse with buffer as an argument. Okay, so what am I passing? I'm passing the address where this array is stored.
Right.
So inside here, arg means the address where buffer starts.
But aren't you dereferencing it with the asterisk?
This is really, so this is where it's useful sometimes to think of this as char star space arg. This is a variable of type char star.
Okay. I think that was my problem.
Okay, it's a confusing notation because normally star arg means, yeah, dereference it. But in this case, it's just a declaration of arg as a pointer to a char.
So is it saying like the dereferenced version of that variable is ignored?
Yeah, that's another way to think about it. If we look at what arg points to, it's a char. But you know, this was a bunch of people in the 70s putting this stuff together, so it may not always make perfect sense to us. All right, is that helpful at all? Okay. So let's take a look at 412. 412, you're writing a different function called start. It returns an integer, it takes two arguments, and the arguments are an integer and a char star star, which might set off panic bells somewhere, right? Don't worry about it too much. Your main program that you're going to write when you test your start function, you can write a main program whose arguments are int argc, char star star argv, and just pass argc and argv to your start function. And it's assuming that argc and argv are the argc argv from a main program. Okay, so we don't need to figure out how to make an argv that's a char star star and so on and so forth. Okay, what's the function do? If you call it with an argc different from 2, return -1. It's an error. If argc is exactly 2, then you want to look at argv bracket 1. If it's not an integer, return -2. That's an error. If it's an integer but it's not positive, it's less than or equal to 0, that's an error, return -3. Otherwise, convert it to an integer and return the value of that integer. So this is close to a piece of what you could do in PA2. If you take a command line argument to say how many sticks you want to play with, this will tell you, was there exactly one command line argument, was it an integer, and was it positive? And in PA2, make sure it's at least 10. So the trickiest part here is testing your code. Writing the code, it's another scanf, right? It's checking argc and then it's doing scanf on argv bracket 1. But the trickiest part is testing it. So to test it, here's my suggestion. Make a test bed called main.c. Declare integer main int argc char star star argv. And then just call start with the same argc argv that you got in main. And save the return value and print that out. And now to test your code, right, type in the name of your program and just hit enter. And argc should be equal to 1 in that case. It should return a -1. Now type the name of your program, space, and an integer. It should return the value of the integer. Now type the name of your program, space, and haha. It's got one argument. If it's not an integer, it should return -2, and so on. So if middle of the night you're trying to figure out, well, how do I make a char star star, and I have to malloc space and all that kind of stuff, you're thinking too hard, okay? Just write a main program, pass argc argv to the start function. And then the rest of this is the usual boilerplate. Link it in with test bed and assess it. So Discord, I still don't want people posting code for their assignments, okay? If you post your ODP and 20 or 30 people are looking at it, somebody's going to write back and say, oh no, you should do it like this, right? And once you see that, you're out of luck. You can't unsee it, right? And the way that you learn programming is by seeing your code and then figuring out how to turn it into something that works. If you see a solution to it, right, you can't go through that process. You can't unsee the solution that was posted. And you also start to believe that this is the correct code. My code, incorrect. This is the correct code. There is no this is the correct code. There's lots of different ways that you can do this. The code that someone posts might be a totally different path from what you were doing. You may have been really close to a solution, except that you were using, you know, the value returned by scanf instead of the value that you passed as an argument, right? But you're going to ditch all of that, and you're going to be convinced that scanf is just flaky and I shouldn't use it and I should do this thing instead, right? So I still don't want you to post code for the code that you're trying to write, but I'm okay if you want to post test bed code, okay? If you're, you know, my code seems to work perfectly, but I'm not getting 10 out of 10 when I assess, right? Does that happen to anybody here? Right, everybody? So my code works perfectly, right? Means that you've got a main program that you're using and you're doing test cases and you're looking at results. I'm okay if you post your test code and the cases you're running and the results, okay? Just don't post the actual code for the ODP itself. But the main program, feel free to do that, and then feel free to comment along the lines of, you know, did you try running it with no arguments? Did you try running it with 3 arguments? Did you try an argument like 2.5, right? Things like that. And part of the challenge in the ODPs is sort of figuring out how to do the QA on your code, the quality assurance, how to test different cases, how to come up with different ways where your code might not work. And that's really hard to come up with in a vacuum, so that's a good groupthink kind of thing. Make sense? Differences there? So don't post ODP 412, but you can post main.c, right? All right, enough there to make a good stab at it? Cool. So I'm going to give you a teaser for later in the course. So I think it was Sam posted a thing in SegFault about the worst way to place brackets in code, because you can put brackets on the same line, the next line, and so on and so forth. And and here's some code, right?
What is going on here, man?
And the worst place was this example had all the brackets and semicolons in the rightmost column, right? Which is legally, technically it's legal syntax, but it's really hard to read and stuff. So I thought it would be cool to like format code like that. So here's what I did. I wrote a short program. So this is using a tool called sed, which we're going to get into in about 4 or 5 weeks. And it's a really short program, right? It uses bin sed instead of bin bash, and it's really 6 lines of code. Okay, and if you know sed, this is easy to write. I wrote this while eating pancakes this morning. Okay, so one-handed typing. Really, really simple. But here's what it does. If I say format parse.c, it turns it into this horrible format with everything pegged over on the right side. And you can compile this and run it, and it looks great, but you can like ruin your teacher's day by turning this in, right? So, and it conveniently gets rid of comments too, right? I have it strip those out, and I could have it left justify everything if we really wanted to make it ugly, right? And there's contests like this. There's contests where the goal is to take a piece of code that does something and try to make it as unreadable as possible. And people come up with all kinds of crazy things, right? And we
using what's it called? The one where you can reassign things. I forget what it's called. It's a compiler thing. Like it's
like a
hashtag
macro,
include.
like a define.
Yeah. Define.
Yeah.
Like define. All
Yeah, you can go crazy with that. So this is a short little sed program, and it can do that formatting. I could also write a similar program. It would be about the same 6 lines that would undo that and put all the stuff back to the spot where it normally would be. But it can't recreate the comments, unfortunately. So we'll get to that in a few weeks, but it goes along with this theme that I keep coming back to, which is the goal should not be to learn 1,000 commands in Unix, right? The goal should be to learn a set of commands that are useful to you and to get as good with those as you can. So you can use VI, you can use Nano, you can use Emacs, you can use Tico, you can use Pico, you can use Notepad, you can use gedit, you can use Notepad++. There's lots of ways to edit code. The most successful programmer is not the person who knows the most editors. Okay, it's the person who knows best how to use their editor of choice. Now in this course I still want you to use VI for various reasons. but down the road, right, and even while you're in this course, find an editor that works for you and just get really good with it. Okay, so sed is one of the tools that's in my toolbox. Didn't used to be, and I kept trying to do things like that, and it was hard, and it took me a long time. And every now and then I'd go back to sed, and I'd say, yeah, okay, I can use that. That's pretty cool, and I'd forget about it. Eventually, it got to a point where I was doing this stuff enough that I actually started to remember some of the ways to use sed, and now it's just like my go-to tool. And when I worked on Wall Street, I used this every day, countless times, over and over and over again. And it was at the point where people in another cubicle would shout, "Hey, Nick!" I'd be like, "Yeah," and they'd say "I'm trying to blah 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 blah," and I'd say $1, $s/caret space ... asterisk curly bracket blah blah blah, and they'd type away and thank you. Right? So this is one of my tools. Your toolkit will be different from anybody else's, right? Because not all tools work the same for everybody. So the real goal in this course, in my mind, other than you got to learn certain things for the exam, but the takeaway from it is you want to come away with this idea of building a toolkit that works for you, and just get to know your tools really well. And you might use a tool for a while, and it's you find something better, or you find you don't really use that, and that's totally fine. So in that spirit, I have a 30-second video break for you on the topic of knowing your tools well. So this is people who use tape measures.
Well, I have seen people do this.
All right, so yeah, get to know your tools. All right, let me talk about gets. So, right, remember gets. Description, never use this function. Okay, so we talked about this a little yesterday. So I have a program here, go.c. So this is just an example of something using gets. So it's got an integer I, right? We always need that. It's got a secret password, which is 19. Okay, so that's a secret. So I should turn off the recorder. And it's got a character array called answer. And it starts off asking the user, do you want to continue or do you want to leave the program? If they say, I don't want to continue, if the answer is no, it'll just return. Okay, so I use the dreaded gets to read in their answer, and I just check the first character of it. If it's an N, we exit. Otherwise, we're going to continue, and it's going to say enter the password. We're going to read in the password, which is an integer, and we're going to compare it to the secret password, which is 19. If it's not equal to 19, we'll say you're unauthorized, and we'll exit. Otherwise, we'll continue and do something like transfer all the money in the account to the person's personal account.
Office Space.
Yeah. It's just rounding the pennies. All right. So I'm going to compile this. I'm going to get warnings about gets. Gets is dangerous and should not be used. I'm going to ignore those, and I'm going to run this program. Okay. Do you want to continue? If I say no, it'll just exit. So that works fine. Do you want to continue? Yes. Okay. Enter the password. Well, if I happen to know the password is 19, I get all the money. That's good. Okay. But somebody comes along, they find my laptop, they're like, I'll try this. Okay, password, I don't know, 42. Oh, I'm unauthorized. Goodbye. Okay, so that works fine, right? Do you want to continue? Yes. Password. My favorite password in the world, all my passwords at Clark are 65. No. So I put in 65. It's unauthorized. Goodbye. Okay. Well, I really like the password 65, so I'm going to do something different here. Do you want to continue? Instead of just saying Y, I'm going to say Y space A. What's the password? 65. Hey, I got the password right. So how did that happen? So when it asked me, do you want to continue, and it said gets answer, I typed in Y space A. Okay, that's a Y, a space, an A new line, a null terminator. That's 5 bytes. My answer array is only big enough to hold 2 bytes. So where did the other 3 bytes go? They went into whatever happened to be next in memory, which was, guess what, password. And that A that I typed, the ASCII code of that is 65. And so it actually changed the value in memory of password to 65. And then when I typed in my password attempt of 65, it said, is that equal to password? Yes, it is. And it went ahead and gave me all the money in the account.
Wowzers.
Yeah. So that's classic buffer overrun behavior, right? And you'd need to know, that you should type in A and all that kind of stuff. So it's a cherry-picked example. But it's the same idea that, was used in some real exploits. Now, if I compile this using a regular GCC, and I try to do this, it tells me stack smashing detected, unknown terminated, aborted, core dumped, with some asterisks and exclamation marks. So normally on this machine, when you say GCC, it adds some extra stuff to your code to look for a buffer overrun, and it will not let this happen. But I compiled it with a switch that said no stack protector, right, which changes how it compiles. And if you compile it with a system that doesn't have stack protector turned on by default, or an older version of GCC or something like that, right, this will just happily read in your input with gets and just load it into memory and step on whatever happens to be there. So that's the whole gets deal.
Why is it still in?
It's still there for backwards compatibility, in case you have old code that you want people to hack. It'll still work. It's usually good practice to try to keep things so that as you add things, older things will still work. Every now and then there's a break, right? So Python 2 to 3 broke a lot of older stuff. Got a lot of people upset. Sometimes it's a good thing to do. All right, so let you out 2 minutes early. Have a good 3 days, and I will see you on Monday. Where's the sign-in sheet?